We're going to be naming our triangles. There's two ways to name triangles, either by angle measures or side lengths. The first one we're going to be doing is based on angle measures. You have right angles, acute angles, and obtuse angles. So, as a refresher, a right angle looks like an L, a capital L, or it can also look like a capital T. Right here's your right angle, also right here. It can also look like lowercase t. Here's your right angle, right angle, right angle, right angle. It can also look like a capital F, right angle, right angle, right angle, even a capital E. Right angle, right angle, right angle, right angle. Okay? On an acute angle, looks like this. And the way you can tell them that they are an acute angle is it's kind of like, aw, a little angle. How cute. Acute. Okay? These are your acute angles. A little angle. How cute. Acute. Then over here you have the obtuse angle. Okay? On the obtuse angle, it's open nice and wide. Okay? It's kind of like when your throat hurts, you go to the doctor. Okay? And then they say, open up your mouth nice and wide and say, ah, obtuse. They're nice and wide. Ah, obtuse. Okay? Now, just to go into a little bit more detail, the right angle, it is 90 degrees. To me, this is the most important one. Okay? The 90 degrees. Because if it's less than 90, meaning if it's less than 90 degrees, but more than 0 degrees, that would be the acute angle. Okay? For the obtuse angle, it's more than 90 degrees, but less than 180 degrees. Okay? This is more than 90 degrees, but less than 180. 180 is a straight angle. More than 90, because it doesn't look like an L, but less than 180. More than 90, because it doesn't look like an L. Okay? That's what I mean by that. Less than 90, it looks like small, inside of a L. Okay? Now, the other way to categorize triangles is by their side lengths. Okay, so, whoops, sorry. Got a little ahead of myself. So on this one, let's look at this. Basing triangles on their angle measure. See this? This is a right triangle. Right triangle because it has a right angle. Okay? On an acute angle, an acute triangle, see how all of these angles, they're small, they're little? Aw, how cute. This is an acute triangle. For an obtuse triangle, right here, obtuse, acute, acute, but this is an obtuse, okay? All obtuse triangles will have one obtuse and two acute, but it has one acute obtuse. Same thing with the right triangle. The right triangle has one right angle and two acute, but it has a right angle. The obtuse has an obtuse angle, two acute, but an obtuse angle. An acute triangle only has acute angles. Next, we base triangles based on their side lengths. So on this, here's the easiest way I can know to help you out. Go something like this. Okay, this is the letter E for equilateral. Okay, this is going to be the letter I for isosceles. Isosceles. Hold on. Okay, isosceles. Isosceles. Okay, and then you have this one, the scalene. Okay, now on this one, notice how many dark sides I have. 3. So equilaterals have 3 equal sides. 3 dark sides, 3 equal sides. Isosceles has 2 equal sides because it has 2 dark sides right there. Okay, now there's a special note to this one. I'll get to it in a little while. The scalene, see how it doesn't have any dark sides? So it has 0 equal sides. Okay, so on this, the special note that I was going to tell you is isosceles, now the way they have it defined is that it has to have at least 2 equal sides. So now it's like it can have either 2 or 3. That's the way TEA wants us to teach it to you, so that's the way I'm teaching it to you. Okay, so at least 2 equal sides, but you still have the 2 dark sides. Equilateral, 3 equal sides. Isosceles, at least 2 equal sides. Scalene, 0 equal sides. When I say at least 2 equal sides, that means 2 or 3. Okay, so now going back to this, based on their side lengths, you can have, trying to do it as best as I can. See how these two are the same? That's an isosceles triangle. Okay, or this could also be an isosceles triangle because it has 2. Okay, now this right here can also be an isosceles triangle, where, trying to make it as best as I can, these two are the same. Right triangle, acute triangle, obtuse triangle, but they're all isosceles. For a scalene, now there's a reason why I'm leaving the equilateral off. Okay, for a scalene, this could be a scalene right here, where none of them are the same size. It's also a right triangle. Okay, scalene on acute, I'm not going to try it right now, but look, scalene on an obtuse. This is an obtuse triangle. All of them are different sizes. Okay, now the one that I left off was an acute. For me, equilateral. For me, an equilateral, they were always the same, but apparently now, or isosceles, sorry. Yes, equilateral, they're all the same. Equilateral, they're all the same. Okay? Now, on this, they also consider this an isosceles triangle. That's why I left it off to the end. They also consider this an isosceles triangle. Equilateral for sure. But they're saying it's also an isosceles because at least 2 sides are the same length. Okay? Hopefully this helps you all out. Bye-bye.